Good morning, everyone. Welcome to day 2 of Catalyst. We're going to get started here in a few moments. So as I mentioned yesterday, this is a very special facility. Not only is CSU a customer of Energy Cap, and also Centrio is one of our wonderful customers as well. And they run and manage the district energy plant here on site, which I know many of you had the opportunity to tour yesterday. And so we are so excited for our keynote today to welcome Brad Buchanan, who's the CEO of National Western, and Tim Kearns, who's the VP and General Manager of Centrio, to talk to us about how they are transforming Denver's energy landscape here on site with a project at CSU Spur. So without further ado, I'd like to welcome Brad and Tim to the stage.
Thank you.
Here's your, are you mic'd up? Awesome. So there you go.
Is it on? Yeah, good. Can you guys hear me? Yeah. All right. So we're going to go through a few things. Who's who? We've got some bios up there for Brad. We won't bore you with all that with him. This one's not on? This one should be on. Yeah. Okay. So, Brad and I've been working together on this project. Now I just kind of got involved not too long ago, but Brad's been with it since its infancy. So we'll give you a little bit of project rundown. And then Brad, who is kind of here from the genesis of the project, will kind of tell you all the relationships and parties that were involved from conceptualization to actually bringing the project commercial. Then we'll do a little bit of a system breakdown and give you some of the components of the system. And then we'll talk about some of the sustainability solutions that we have and the benefits and advantages that this brings, not only here, but there's a lot of other interest in this area and other areas about doing these types of projects. So a little bit about Centrio. We're a district energy provider. We operate in a lot of different cities. And this is really probably our most pure P3 or public-private partnership with the city of Denver involved in the National Western Center. We really have a good synergy there. We also do the same thing at Eastern Michigan University in Ypsilanti. I love putting Ypsilanti on a map because most people have heard about it and think about it, but maybe don't even know where it is. We also have a relationship, similar P3 relationship with LSU in Baton Rouge and with Syracuse. So it's an area that we play pretty heavily in, as well as operations in Seattle, California, New Orleans, Chicago. Chicago is one of the biggest district cooling systems in the entire country. So to give you a little bit of a rundown on the project. So we manage and design, build, process development of O&M and strategy, and provides 100% O&M services to the city of Denver for under a 40-year agreement for operating the CUP. Redevelopment was envisioned to convert the campus from 94 acres, the original campus, to the 250 acres. And does that include the original triangle piece, or is that just this site?
250 includes the entire site.
Okay, so the original Western Center sits across the railroad tracks. This is the new development. And I guess the strategic long-term plan is redevelop this and then redevelop that piece. So it'll be more than doubling in size when they're done. So we Centrio partnered with AECOM to form EAS Energy Partners, which was comprised of Centrio, AECOM, and Saunders to do the design, build, construction of the facility, and then integrate it to all the campus energy systems. The system would be approximately 4 megawatts thermal when it's completely operational, which that actually is now, but it can be expanded. We can actually add another Shark unit, which is what actually does the separation of the solids to give us the sewer water that's usable. The project was formed in 2015 by this group of partners. So it's the City of Denver, the National Western Center, CSU, Colorado Art Museum, Natural and Science, and I'll let Brad take over here and kind of go through some of these relationships and partnerships, because there was a lot of synergies that had to come together to make this work with kind of a not I would say unproven technology, but something on this scale had never been done before. So Brad?
My arrowing?
Yes.
Yep, that'll work. So good morning, everybody. Welcome to Denver. Welcome to the National Western Center. How many of you are from Denver Metro? How many of you have heard of the National Western Stock Show? So some more, yeah. So the National Western Stock Show has been here for 118 years and has had a challenging, I'll use that word, challenging business model for 117 of them. They have 16 days of revenue and 365 days of expenses. So back in 2010-ish, Stock Show was considering moving out towards the airport to the Gaylord Convention Center Hotel and locating there. And leadership in the city said, we're not going to allow that to happen. And the National Western Center concept was born around it as a 365, so year-round destination around the future of food and an agricultural hub around education, entertainment, and agriculture. We've not found an analogy to the National Western Center anywhere on the planet. Quite frankly, we have found components of it, but in my opinion, and the reason that I was interested in the position as a CEO of the National Western Center is that I think it's tackling some of the most relevant and pressing issues on the planet and our country today. Sustainability, climate change, resiliency, equity, community equity. This campus is located nested in the Globeville area, Swansea communities. 80216, the zip code you're in right now. Don't breathe deeply because 80216 is the most polluted zip code in the United States. These communities have been living with this their entire lives for generations. Air, soil, and water pollution. We're not here by accident. The National Western Center exists here because there were stockyards here. 40,000 head of cattle, sheep, and hogs a day came through here by train, took their last Green Mile walk, left in boxes. We fed everybody kind of west of the Mississippi. In the 20s, all of this was stockyards surrounded by packing plants. That drew immigrant populations because there were high-paying jobs, so lots of immigrants coming to this area. This is also the bottoms, right? Every city in the United States, big city, has an area just like this. Everything, yes, it drains downhill. And so downhill is where you put all the noxious uses. If you're going to put a slaughter plant where you're going to dump guts into the river, you don't do it upstream of town, you do it downstream of town. And that's why every city has a place like this. It's the bottoms. It's where the water treatment is. It's where the industrial is. And that grew these immigrant populations, which is also what contributed to the extensive pollution. So these missions around everything I just talked about and connecting the urban and rural place. I mean, what's more relevant than that conversation? Look at our political landscape today. Everything is us and them. I am a former planning director for the city of Denver. I had an architecture firm in Denver for 25 years, but I live and my family operates a cattle ranch 40 miles east of here. So I kind of have a foot in both places, and the National Western Center is where those communities are coming together. I just talked about everything that has to do with this slide. So good news. So I can skip by that one. Sustainability, obviously, what we're talking about today on this campus, and in this project, I was mentioning a few minutes ago to Chris here that, when this challenge presented itself, and I've got a slide of the pipes later, it was a land use issue. They've got these pipes laying above grade that are blocking our access to the river. We were presented with a choice. Were we going to pursue this potential sort of kernel of an idea, or we were gonna heat and cool this? We were going to energize this campus in more traditional, less sustainable ways. And it was going to be complicated. It was going to take everything on this project is complicated. Tim showed the partner slide, and I'll show you in a few minutes the agreement rubric of this project. We knew it was going to be complicated, But we believed in it, and the partners believed in it. And I was mentioning earlier in the conversation, this has been. I wish we would have done we had documented, like filmed the process, because it was an amazing experience and sort of testament to human spirit, people's commitment to that which to what many people said was impossible, simply because not because it wasn't possible, but because it had not been done before, and certainly never been done at this scale. We were doing so we set the bar for the entire project, really, with this system, when we said we were going to capture and heat and cool 1.3 million square feet of new vertical construction with the waste thermal energy out of 272 and sanitary sewer lines. And yes, I've said that many times before. So the district heating and cooling system, renewables, we have a community solar garden, PV goes back into the system, goes out to with reduced cost energy to the low-income communities that surround us. And then the resiliency is a big thing. We're designing and about to install a whole battery backup system. So this will be an emergency refuge if everything goes to hell in a handbasket and there's no power in Denver. The process started with the National Western Center Master Plan, and this was done when I was the planning director. So I feel so privileged. I get to come to work every day and implement something that I was at the table for to actually create. And that just doesn't get to happen very often. A lot of times master plans sit for a long time. This one kicked off in 2015 with the National Western Center Master Plan, sort of describing a lot what I've talked about. And then it went to the voters in 2017. Jen, am I right? Was it 2017 or 2015? 2015 was the 2C vote that was a general obligation bond vote that produced about $765 million that has covered a lot of what you've seen so far, absent the three CSU spur buildings, which were done through state funding. CSU, obviously, you're seeing their amazing facilities here. I hope you all get lots of chances to check out all these buildings. They are all of them one of a kind, and CSU is doing just a remarkable job of standing up programming around the topics of food and ag, water, resource, and animal and human health in these three facilities. So this document is where all this came from. There's the pipe. So when I was planning director, we were talking about this river's edge, and this pipe is laying above ground. And to the left of this picture, between that pipe and the South Platte River, I cannot use words that would fully give you the understanding of what the experience of the place was between the pipes and the river. It was an uncontrollable area, because it would take two of us to lift one up to get on top of the pipes. And there was this stretch of land, 100 to 150 feet wide, between the river and the pipes. It was over 2 miles long, with access only at the ends. So safety patrol could see it. Police could see across the river to it. You just couldn't get to it. And bad things happened there. It was dangerous square footage in our city. And we wanted to get access and turn it into what you see today, which is 6 acres of riverfront open space that's now completely reclaimed the riverfront and the wild space along the river. What I want to come back as in my next life is a lawyer, because every one of these arrows is an agreement, and none of them are short. But here's the I don't have a pointer. The main one is the campus energy agreement. That's between the National Western Center and the EAS and energy partners. And Tim referred to it as the city. We are financially backed by the city. Technically, the agreement is with our organization. And then EAS obviously contracted with Centrio and Saunders and AECOM, and then the city built a portion of the ambient loop system. We had an agreement with Metro Water Recovery, which is the producer of the operator of the effluent, which is the spark for the whole system. We have the city supports us, that we have a contingent credit agreement, commitment that from the city that basically backs us. I mean, the city co-signed on our car loan. We don't have any money. Been around for 5 years. We don't have any money. We don't have any credit. We have few revenue streams, but we have the city and Colorado State University standing behind us saying they're good for this. And then we have 2 sub-agreements with Spur, CSU Spur. They have 33% of the thermal capacity, and the Stock Show for their headquarters. That's what's under construction right across the street here. You'll see the concrete block going up right now. They're a user. They have just shy of 10% on the thing. So this is the map. The railroad tracks are what goes from southwest to northeast. That's all phases 1 and 2. Everything on all those colored building footprints are either under construction or completed, except the blue one. And the blue one is a 400,000 square foot equestrian center, a 200-room hotel, and an 800-car parking structure. That is in procurement right now. We hope to start construction on that in the next year or so. Number 8 is the big livestock center. That's a 350,000 square foot facility, 5,500 seat arena, 185,000 square feet of expo hall space. The north end is the yards, the Stockyards Event Center. It's a smaller venue. I think those are blue buildings. I can't really see blue buildings. Those are 3 CSU buildings. You're in number 12, the Hydro building. There's some historic structures just to the east there. By 13 is a livestock exchange building where the authority office is. And then we built, there used to be train tracks ran through all this. We did a consolidated main line, which is number 15. There's a rail platform at number 17 right there. We did the riverfront, which is number 3. So as Tim said, we're getting all this done. And then the Stock Show, which currently really operates east of the tracks by number, I think that's 18. They will then move over here, and then we'll develop the triangle, which could be another 1.5 million to 2 million square feet. So about 1.3 west of the tracks. So it's a huge infrastructure and vertical construction project as well. Tim's going to talk about the system.
Thanks, Brad. That was a great overview, and you can tell Brad's passionate about this. He's been living it and breathing it for some number of years. So he's got it in his blood, and it's fun to watch somebody talk about a project that they've started and brought to fruition from that. So we came in after Brad had kind of built his vision, and we did the central utility plant, which we have a 40-year agreement to run that plant, and we're responsible for it. So I'll go through. And if you went to the plant yesterday for a tour, raise your hand. Were you there yesterday? Anybody coming today? Okay, so you're going to get the same spiel there, but you'll just be able to put your eyes on the equipment and the things we're going to talk about here. So
it never gets old, though. It just never gets old.
Hey, when you deal with things that spin around, they're going to break. So and that's what we do. I mean, in our industry, Brad's developing real estate. We deal with pressures, temperatures, and flows. So that's what we manage. So if you look on the far left, that's the wet well. So what we did is when they put the Delgany underground, they put a siphon on the bottom of it. So we come out at about 45-degree angle and go into a wet well. And I'll show you that when you're on your tour later if you come over there. So the wet well collects the water from the Delgany, and we have a pump in there. And that pump pumps it into the central plant where it goes through a filtration system. So the first piece is a macerator. So it takes all the solids that are in there and shreds them up real fine. And then it goes through a system called a SHARC, which is a sewer heat recovery unit, cleans it up even more, and then it goes into a plate and frame heat exchanger. Now you think, people think about sanitary waste, and they always typically think of one thing, what's come out of the toilet. But the heat is coming from your washing machine, your shower, it's all other, the waste, the actual waste has no heat value to it. It's all coming from process. It's coming from your wash machine, your dishwasher. So we get all the stuff out of it. We put it through the heat exchanger, and then we're tied into the ambient loop. So if you see where it comes from the filter through the heat exchanger and then goes into the clean closed loop, then that provides water to the buildings, and all of the buildings have heat pumps in them. So the heat pump will allow each individual heat pump using the effluent or using the ambient loop to either heat or cool whatever part of the building and operate that building however the owners want to run that. So we consistently provide anywhere from the low end 50-degree to the high end 75-degree water. And we're kind of agnostic as to what the buildings want to do. We're just giving them BTUs to manage and run their building how they want. And then they bring the water back to us. Now, if we have extreme situations where there's a really hot spell or a really cold spell, we do have boilers for backup. So we have some package boilers that can come on and put additional heat into the loop if needed. And we also have cooling towers, so we can put some additional heat rejection into the loop if needed. So we operate on very close temperature bands, right? If you were doing centrifugal chillers, we would be sending out 40-degree water, using a lot of electricity and compression to make that. We would have cooling towers using a lot of electricity. Same thing with boilers. We'd be consuming a lot of gas. So this is really very little electric goes into this. And there's a lot of times where the system itself will sustain it. We call it kind of the null mode, where we're not really running anything. The loop is just sustaining it. And some of the heat pumps are putting heat in, some are taking heat out, and it just kind of manages itself. So if we look at this, Brad showed you the pipe that was moved. So then we put in the waste screening system that keeps the solids out of the closed loop. And then most of you are probably familiar with plate and frame heat exchangers. So we have those in the plant. We have one that separates the solids out. Then we have 3 that are set aside in case we need to use the cooling towers that are tied to the cooling towers in the ambient loop. Then the underground pipes, again, that's HDPE, which is, if you've ever worked with that, it's a really interesting product. A lot of times when you're doing stuff underground, it tends to be carbon steel or some other type of metal. But first time I saw them do this, they brought in, they're like 40-foot joints of pipe, and they weld them together with heat. So they basically have a thing that heats and presses together. It's a really neat process if you've never seen it. And it doesn't corrode. It changes your whole water treatment profile. If you're using carbon steel, you've got a lot of other things you need to add to protect it. And then at the end, the buildings have heat recovery chillers or heat pump type systems that, like I said, they can either, just like a typical ground coupled heat pump like you might have, or if you're using geothermal, same technology, but we're just using our ambient loop instead of pulling water out of the ground. Turn it back over to you, Brad.
So it worked. It's simple science, but it's on a scale that's not been done before. And the process of defining what the performance was going to be and translating that into an agreement, a 40-year design, build, finance, operate, maintain agreement that sets KPIs, right? We're just buying BTUs at a delivery point. That's what we're buying. Everything else is their problem. That's what we liked about this. This is your issue. You just got to bring us BTUs at this location. We knew the science was solid, but we were partnered with. I mean, the curtain was pulled back. So we had engineers from Centrio and AECOM and all sorts of experts who were in the room. We had finance people, because this is a big darn deal, complicated financing deal. We had Metro wastewater, so we had to, the flow, we had to talk about what the flow was going to be and to get those kind of commitments. We are in the state of Colorado. You've heard of water rights, and the saying in Colorado is, what's whiskey's for drinking, water's for fighting. Water is gold here, and they have water rights, and they're adjudicated, and they have senior water rights. We had to create legislation with the state. We are sewer water right 1. Number 1 in Colorado. There will be more, because we need to make sure that this thermal capacity doesn't go away when the next group, and there's a whole bunch of things upstream looking at this right now. There will be more, but we need to make sure we have our capacity protected. So we created all these criteria really together, and then we turned it on. Okay, were we right? Let's confirm we were right. We got 2 pieces of good news back. One, the heat exchanger process is more efficient than the conservative engineers said it would be. So we're getting better efficiency in the heat exchange process. And the second thing is the ambient loop is more efficient. HDPE buried in the ground does not have very much thermal loss. So as you said, it can run in this null mode a lot because we're not losing that much energy, as much energy in the ground as we thought. And so the punchline is we're avoiding 2,600 metric tons of carbon, a reduction of 70% here on the campus, equivalent to the 6.6 million vehicle passenger miles annually here. So it's not nothing. It's making a difference. It's saving the equivalent of 5 Olympic-sized pools. And this is fascinating to me. It's only, and the truth is this is overstated. It is reducing the ambient temperature of the effluent in the pipe by less than a degree and Fahrenheit. So there's more capacity. That's how this all happened. When we went to Metro Wastewater and said, hey, we want to bury your sewer lines, they said, you can't do that. We're bleeding waste heat out of those lines. And as Tim said, yes, there's waste in there, but most of what's in there is hot water from showers and washers and dishwashers and clothes washers. So they spent a lot of money not just cleaning it before they can put it back in the river, but cooling it to get it down so that it doesn't harm the ecology. The delta, the change is remarkably small. That's bad news on one regard, but great news in terms of how much capacity there really are in these systems. Cost of ownership. It's basically a 40-year break even. That's the punchline. I will tell you that is a very conservative number. The private sector, their assessments are coming in less than that, but our calculation is that it's about a 40-year break even. One of my obsessions right now is I am going to get legislation through the state, I hope in the 25 legislative session, to add the words, 3 words is all I need to add to an existing piece of legislation, sewer heat recovery to the eligible resources for renewable energy credits. That is a game changer. If we can sell our energy credits, everybody will want to do that. And we are making progress in that regard, and I hope we'll be able to do it next year. And Tim's going to close us out with some ops.
Thanks, Brad. Yeah, so again, as I mentioned at the onset, we're one of North America's largest district owners and operators. We specialize in sustainability, low-carbon heating solutions. One of our biggest operations is in Seattle, and if anybody has any level of familiarity with what's going on in Seattle with energy policy, we have a full team of folks working on managing that. We even have a mad scientist, as we call him, that's managing a lot of that around the carbon credits and the things going on there. So we are really focused on that. We have a whole team. Megan Reister, who I believe you've met with Megan, she's in charge of our sustainability, so it's very important to this project, right? The university has a lot of expectations. National Western Center has a lot of expectations, so we're really working to meet all the sustainability goals. We do have on-site operations at this facility, but we also have a 24-hour operation in our Houston location where we have our National Operations Center. So we can see and manage and operate this facility from our operations in Houston. That also manages several in LA and one in Portland. So we have supervision. We have, somebody has eyes on that facility at all times. And then, there's a community engagement plan and a commitment to the community. So we're here, we're 40-year partners on this. So we want to see it grow. We want to see the National Western Center continue to grow. We embrace their philosophy about the sustainability of what they're trying to do here. We love the idea that it's not just the energy and the BTUs, but it's the focus on creating agricultural sustainability for the future and educating and teaching young people and anybody that's willing and interested to learn about the ecology of what we need to do in the agriculture and kind of the history of what's happened in this area. So if you have anything else to add, Brad?
No, I think we're good.
All right. So anybody have any questions for us?
What are you planning to sell your carbon credits for if you get approval?
So they are state credits, and all the users are nonprofits. So there is a resale marketplace, and they typically trade at about 85 to 90 cents on the dollar. It could be, it should be some number of millions of dollars a year. It will go a long way to paying for this system.
If you were to get those credits, how much do you think it would reduce your 4 years or retention?
I need to do that calculation because that is a great question. It can darn near pay for the system, like close. I need to find that out because what I actually want to say is that it will pay for the system. But you know, long way between here and there. But these exist. Sewer heat recovery renewable energy credits exist in 5 states currently, and so I have pretty good data. They're all on the East Coast. DC, District of Columbia, is the leader in that. They have the most progressive recs for sewer heat recovery. But I have pretty good data. And we know what the marketplace is, and we know, and they're reliable because there's a lot of tax credits that are iffy, right? People can buy them and then maybe they get denied later. These are very solid credits. So we'll see. Hopefully we'll know in a couple of years.
Yeah, hi Brad. Just curious, you mentioned that you guys are in the process, I think, of bidding out some work for a 800 vehicle parking garage.
Yeah.
One of the things I hear a lot in the sustainability world with EV or fleet electrification is concern over parking garage capacity, weight capacity. Is that something you guys are taking into account for kind of additional weight from electric vehicles down the road?
So I think parking garages are, I am going to answer your question. I'm not trying to skirt it. I think parking garages are really interesting structures right now, thinking about what other uses they can be. And I think my experience is that helps to solve for that problem. When I had my firm, we always, the most efficient parking structure is a helical garage where it's all sloped. You know those garages where you're just constantly driving, you're parking on a slope. Now you'll see they're all being built flat with speed ramps on the end because we're thinking about alternative future uses. With the incredible growth of EVs, now I think that thinking is a little bit like, oh, okay, well maybe we still will be driving some in personal vehicles. But we're still designing them for future uses, and future uses are for a lot of different things. That can be heavy pounds per square foot users. And so I think we are going to be okay, but I think that's a great question too. I hope that we're going to get more efficient with batteries too, right? And with weight and batteries.
With the 1 degree delta T, how far off that is from the design models, and is that because of the efficiency of the offtake or lack of demand?
Well, the 1 degree delta T is on the plate frame heat exchangers. And so it's really, like Brad said, it's operating better when we perform because we designed around 2 degrees. So we figured a 2 degree approach on the loop system, and we're actually operating at 1. So it's actually 1 degree or 50% better than design.
So how much water do you need to pull out per megawatt of thermal? And what is the resource in those massive water mains, the thermal resource? Are you anywhere close to maxing out?
No, and I don't have those numbers, but I know that the plant is designed with the equipment that's in there. that we can pull out 4 megawatts. I don't know what the maximum is, because the flow in the Delgany goes up and down, right? So we kind of looked at it, we've got some flow sensors we're installing to get a better handle on it. So it depends upon the flow level in there. We're set up, again, we're at about a 45-degree angle down in the bottom of the pipe. So if as long as it's above that, we can pull out whatever is in there. But I don't know what the maximum amount of heat that is in there, but, Brad made a good point earlier, we need a certain amount. If we have people upstream pulling some of that out, now we're getting less. But I feel like, we could easily double what we're doing coming out of there.
I know that Metro Water Recovery's goal is a 5-degree reduction, and we are less than 1. Cooler is better for them. And it's a challenge too, because sometimes we're pulling heat out, sometimes we're putting heat back in too. But on balance, the effective reduction is less than 1 degree. And these pipes, for you guys, are you going to show them will you look in the wet well?
We can if they want to go over there.
Well, talk them into looking in the wet well, because it's terrifying. There's these 6-foot pipes, and for you kayakers and rafters, this is like class 3, class 4 rapids down there, and that pipe is half full, and it is zooming. So that's, when you see that, it's like, oh, I understand why what we're doing is like BBs on a battleship in terms of actually impacting the temperature. There's a lot of capacity there. If you want to go down a rabbit hole, Google Sewer Heat Recovery Baltimore, and they started out with one system, and they're now daisy chaining up and down rail lines with that have major, because rails often follow rivers, which follow gravity, which has their sewer lines, and they're testing for adjacency of high density areas next to these major arterial sewer lines, and now they're thinking they're just daisy. I think they've put in like 5 different pods now, and they will be larger than us at some point. That will piss me off, but they will be larger than us at some point.
Hi, good morning. Marcus from Cal State Fullerton. Sorry we came in late, but did you say the wastewater coming in from the residential commercial was 60 to 75 degrees Fahrenheit? And are you picking up any additional heat from the digesters?
No heat, no additional heat is being added in the process. Mm-hmm. And the temperature typically is about 75 degrees.
Okay. And then you said you had a facility in Los Angeles?
We have some traditional district cooling facilities in LA, not a sewer heat recovery system.
Nobody's asked the really good question yet. What went wrong? Come on, don't you want the juice here? Don't you want to know the hard part? You do want to know the hard part. This is this important safety tip, and I have one really big one. We designed a system for 1.3 million square feet of new vertical and had a timeline when those buildings were going to come on. And so the deal we cut, it's like a mortgage. We bought the whole system. And so we bought a full system with assuming there were going to be these 1, 2, 3, 4, 5, 6, 7 users. Then a pandemic happens and construction prices increased by 50%. And we thought we were going to be 100% operational on 1.3 million square feet in 2023. That will not happen until 2028. I'm paying for 100% of the system today. And so these projects, these systems work really well with a lot. The bigger they are, the better they are. The economy of scale is a huge piece. So my advice and the counsel I'm giving some of the folks upstream who are looking at phased projects is thinking about how to phase them so that your energy cost relative to your occupied square footage matches. We're out of whack right now. We are paying what we agreed to pay, and what Centrio and EAS said they would give us, they're giving us and doing a great job at it. But we don't, like you said, they're agnostics to what happens downstream. Their system's going to produce the capacity, and it is a little different way to think about it. You're not buying like kilowatts. We're buying capacity. CSU's deal says they get 33% of the capacity, and whether they cool this space to 68 degrees or 72 degrees, it's negligible, because it's just the fans. It's the electric to run the fans. The capacity is there to cool to just darn near any temperature you want to, or heat it to whatever temperature you want to. So it's kind of a different way of looking at what energy value is.
When you get up to full demand, do you anticipate that delta T going, up higher delta T? You're at 1 degree Fahrenheit now. If you get the full 1.3 million on, do you anticipate that going to 2 degrees Fahrenheit?
No, because the system is designed at full capacity. So it's actually 3.8 megawatts thermal is what it's designed at. And, we don't envision that changing once we're running at full capacity. So we'll just be running more pumping horsepower. Right, so when you see the plant, we have a bank of distribution pumps. And as there's more capacity being taken out of the loop, we'll just run more flow through the system.
This will probably be the last question, I think.
With all of the electricity that you're using within the plant to run the pumps and the heat exchangers and everything else, are you guys doing a study on whether that is more efficient than running the cooling tower at each of the individual buildings as far as just a electrical use side of things?
Well, it is much more efficient because we're only running the pumps. We're just running distribution pumps. If we run the cooling towers, we're running cooling tower pumps, we're running condenser water pumps, and tower fans as well. So without that, the only thing we're running, so if we, and I haven't done this, so if we were to break it down into, how much power per MMBTU or how much power per ton hour, which is on my plate to do those calculations now that we've got some data, it would blow conventional generation processes out of the water. I mean, we're talking tenths of pennies per ton hour. It's just so efficient. It's almost, the cost for utilities, if the system is operating the way it's supposed to, is almost negligible. We're paying pumping horsepower.
And we're saving square footage in the buildings. All the buildings have less equipment in them. It's expensive
So
to
the
build
entire
that.
plant is about 8,000 square feet. So if you had 1.2 million square feet of space, that you're trying to put conventional heating and cooling equipment in there, in each of these individual buildings, you would be tying up a lot of space in each of those footprints.
Huge savings in manpower, huge savings in maintenance, and FTEs that are doing. I mean, they have one person in the cup. Brian's over there. He's their guy, and he knows the system inside and out. But he's kind of there to make sure something doesn't catch on fire or if something bad happens. I mean, it's being run out of Houston. It's saving tons of manpower.
They talk about the perfect design for the perfect system can be operated by a man and a dog, and the man is there to watch the system, and the dog is there to bite him if he tries to touch it. Yeah. So again, a system like this is really about controls because you get into big boiler systems, big chiller systems. You've got a lot of moving parts, right? You've got a bunch of different flows going on. We're pumping an ambient loop. That's all we do. We circulate it, either put the VTs in the building or take them out of the building. And the Delgani's doing all the heavy lifting.
Hey, let's give a round of applause.
Thanks, everybody.
Thank you.